Words about me. My name is Martin. I'm coming from Sofia, from Bulgaria. I'm one of the guys there who organizes events in the local Java community, along with a few other guys. I'm also running my own consultancy called Coffee Cup Consulting, and I'm a big OpenJDK and Oracle database enthusiast. You can follow me on Twitter. I tweet about events, technology, and stuff like this. So I also have a book on RabbitMQ, which I authored recently. And this talk was partially inspired by the book. The book basically covers the message broker from start to end. It has some more advanced topics such as security, performance, and internals of RabbitMQ. And at the moment, I'm also working on a book for Java 9, which expectingly should be released in around July next year, maybe not, we'll see. So about this talk. This talk basically we will cover how does the Spring Framework provide integration with RabbitMQ, and why should we prefer to use the Spring Framework utilities rather than the RabbitMQ Java client library. We'll see how both work, and then we'll basically compare what are the pros and the cons of each other. First, we'll start with a brief overview of what RabbitMQ is and messaging in general, and then we'll move to Spring RabbitMQ. So in general, messaging, as most of you know, provides a mechanism for loosely coupled integration of systems or components in a system. And typically the central unit of processing is a message, which has a body and a header with some message attributes. Typical use cases of messaging could be for example, aggregating logs from different types of systems, or from offloading long-running tasks from a graphical user interface to worker nodes. And there are really a lot of other use cases, which we'll cover some of them when we talk about RabbitMQ. Typically, there are a variety of messaging protocols, such as AMQP, XMPP, MQTT, STOMP, and others. However, each particular messaging protocol may provide some level of vendor lock-in. So if you decide, for example, to go with STOMP or MQTT, you may be locked to a particular message broker or a set of message brokers that support this type of message broker. Typically, RabbitMQ implements the AMQP protocol, and in order to get a better idea of how AMQP positions as a protocol compared to the others one, we can look at this chart. So basically, first of all, the goal of each protocol is quite different. So AMQP basically targets to replace all proprietary protocols and to provide a common messaging protocol that should be implemented and used by most message brokers. The idea of MQTT, for example, is different. MQTT targets devices with a restricted set of resources. And basically, MQTT is really a minimalistic protocol that allows us to establish some form of communication between different types of devices. For XMPP, the original idea was chat messaging. So basically, XMPP was derived on the need to have a messaging protocol for Jabber. And for STOMP, the idea was to have a messaging protocol which is targeted for message-oriented middleware. Meaning that, for example, you would like to easily integrate with any type of message broker from your Ruby or any other type of scripting language. And for that reason, you can implement the STOMP protocol in your messaging broker. In terms of format, AMQP and MQTT are binary protocols. They really try to optimize the payload that you send to the message broker. XMPP is XML-based, and STOMP has a very simple text representation. In terms of API, AMQP is basically divided into different types of classes that, for example, allow you to create some types of items in the message broker, to send a message, or to subscribe to the message broker. And it has about 40 methods in the RabbitMQ implementation. On the other hand, MQTT is fairly simple, and this provides a lot of limitations. So MQTT basically is lacking a lot of operations that are provided, for example, in the AMQP protocol. And each type of operation has 2 or 3 specific packet types. For example, for sending a message to the broker, we have 2 types, such as publish type of message and publish accept type of message, which is sent back from the broker to the client. With XMPP, the XMPP specification is quite extensible. It defines different types of XML elements that have different subtypes, and basically you can have different XMPP XML-based requests with different types. And it's quite extensible. There are a lot of extensions to XMPP that you can use. And the STOMP protocol is also fairly simple. It has about 10 basic commands. So this, in a way, gives you some basic idea of how big is the API provided by one or the other protocol. In terms of reliability, AMQP and XMPP provide a fairly good amount of reliability in terms of acknowledgements. And both AMQP and STOMP provide the so-called messaging transactions. However, for the AMQP protocol, it's not really recommended to use transactions because they are quite slow. So you better go with the acknowledgements. In terms of security, both AMQP and XMPP provide a good built-in level of security. For MQTT, there is no built-in wire connection security, and authentication is fairly simple. You have to provide credentials in the MQTT header. For the STOMP protocol, this depends really on how does the broker implement security for STOMP, because STOMP is targeted for implementation by different types of protocols, and RabbitMQ, for example, provides also support for the STOMP protocol. In terms of extensibility, AMQP and XMPP provide points to extend the protocol with some custom operations or some custom attributes in the message header. However, this is not the case for MQTT, and for STOMP, it is again dependent on the message broker. So this is basically a relative comparison between the different protocols. And in terms of different message brokers, a particular message broker can implement either one or more of these types of protocols. So typically, there is really a big choice of message brokers you can choose from. Sometimes you may be wondering which one to choose from, which one is best for my particular use case. And the question really is that it really depends on what you want to achieve. Some brokers basically behave better based on certain type of data than others. And in particular, we'll look into how RabbitMQ basically performs in certain scenarios. In terms of some common characteristics of the message broker, each type of message broker has to provide some certain common characteristics, such as, for example, the ability to securely send messages between a client and the message broker, whether that's the publisher or the subscriber. So basically, you need to have a way to provide secure message transfer, also to have means for authenticating and authorizing message endpoints. The other common thing about most message brokers is that they need to provide some form of internal message routing, where you would like to route a message based on some criteria to one or more subscribers. And the other thing about the message broker is that in most cases it needs to provide some form of persistence, where you can persist the message for resiliency reasons. And last but not least, brokers provide the ability to subscribe, to have clients that subscribe to the broker. So these are just a common set of characteristics for a message broker. And in particular for RabbitMQ, RabbitMQ is written in Erlang. Has anyone of you used Erlang in a project? One person? I think this is a progress. You're the first one I see that. Ah, okay. Okay. Yes, that's true. It was developed by Ericsson, but I think RabbitMQ is one of the most distinct applications out there that runs on top of Erlang. And the fact is basically that what's specific about Erlang compared to the JVM, Erlang also has its own virtual machine that executes Erlang source code. However, it's the fact that Erlang developers do not need to provide some synchronization between multiple processes. This is done basically by the Erlang virtual machine. And processes in Erlang communicate by means of message passing and not by means of synchronization, as the JVM works. And this means basically that you can have hundreds of thousands of Erlang processes, and this is fairly resource effective. You don't have to care that each process may consume a lot of resources. And for that reason, basically, the Erlang language proves to be very convenient for that type of applications, such as message brokers. Another interesting thing about the AMQP protocol is that it's programmable. So the AMQP protocol may not be used only to publish messages to the broker and subscribe to the message broker, But also it provides you with the ability to create the different types of elements such as queues, exchanges, and bindings, which we'll see in a few seconds, inside the message broker. And the other thing, as we already mentioned, is that AMQP is an extensible protocol, and RabbitMQ in general also provides a mechanism to write plugins. It has support for other types of protocols such as HTTP, STOMP, and MQTT. And you can roll out your own Erlang plugin for RabbitMQ. However, that may not be so easy as there is not so much documentation about this. Some users, distinct users of RabbitMQ, for example, are JP Morgan. They state that they use on a daily basis around 1 billion transactions that they process to the message broker. Some other distinct users are Google, Nokia, that use RabbitMQ for real-time traffic maps. They have an application that they use it for. And some of those users typically state that they process between 15 and 20,000 messages per second, which is actually quite performant. AMQP in particular derives its origins from the financial industry, where there was a need to process really a high volume of messages for various financial operations. And in order to achieve that, the AMQP protocol defines the so-called channel. A channel basically is a virtual connection inside a single TCP connection that's basically more efficient than creating multiple TCP connections for connecting to the message broker. And the reason for this is that basically the TCP handshake is quite slow, and the guys in the RabbitMQ team decided to optimize a bit this by providing the ability to create multiple virtual connections inside the same TCP connection. And also the AMQP protocol defines 3 main types of elements. These are exchanges, which are the endpoints to which a message is being sent to. You can think of an exchange as a logical endpoint. It's nothing more than a simple name that you use in order to send a message to the message broker. Queues, on the other hand, they are the storage mechanism for your messages. They basically store messages and allow for subscribers to receive those messages. And the bindings basically are the glue between the exchanges and the queues. They provide basically a mechanism where you can route messages from the exchanges when they are received to the queues. The other specific thing is here that subscribers receive just one message from a queue. You cannot have 2 subscribers receiving the same message from a single RabbitMQ queue. And basically that way of publish-subscribe is established at the level of the message broker. You can have multiple queues bound to the same exchange, and in that regard you can send a message to multiple subscribers by sending it to different queues. Each message basically can be published with a routing key, and that routing key should match a binding key so that the message is delivered to one or more queues. And in that regard, basically, we have different types of exchanges that are defined by RabbitMQ. We have the direct or default exchange, where a message is being sent to exactly one queue from an exchange. We have the topic and the Fanout exchanges, which implement broadcast and multicast type of communication at the level of the message broker, where we send a message from an exchange to one or more queues in the message broker. And we have the so-called headers exchange, which is a more specific type of exchange that allows you to route messages not based only on a single message key, but on multiple message keys. And that may be useful in scenarios where you want to have some more complex routing based on multiple keys rather than a single message key. And now if we look at each particular of those types briefly, a default exchange really is very convenient for point-to-point type of communication. For example, you send a message to the default exchange, which is with an empty name. As you can see here, we have an exchange which is specified with an empty name. And that exchange basically is a system exchange defined by RabbitMQ. When you send a message with a key of general to the default exchange, which is AMQP, it is being delivered to a queue which matches the name of the message key, which in that particular case is general. So RabbitMQ determines that we have a queue named general, and it delivers to that queue those messages. Now, if we have more than one subscriber to the general queue, just one of them receives the message. In that regard, we have the so-called notion of competing consumers. Just one of the subscribers receives a message from the queue. In terms of direct exchanges are pretty much similar to default exchanges, but the idea there is a bit more general. A direct exchange has a name, which is, for example, the chat exchange, and you specify some key to the message that you send to that chat exchange. In that particular case, the message key is called bGeneral, and that message key must match the binding key of the binding between the chat exchange and the general queue in that particular case. And in that regard, the message is delivered to the general queue, where it can be consumed by exactly one subscriber. For Fanout exchanges, when you send a message to a Fanout exchange, it is sent to all of the queues that have at least one binding to that exchange. And this basically implements broadcast type of communication at the level of the message broker. And for topic exchanges, you can specify a message pattern for a key. In that particular case, I have warning.some sign. And when that message is sent to a Fanout exchange, to a topic exchange, basically that message can be routed on one or more bindings based on the matching of that pattern with the binding key. So this is basically the way that RabbitMQ operates and provides some way of routing messages between the exchanges, which are the endpoints that receive the message, and the various types of queues. In terms of clustering, to finish on the topic of RabbitMQ, clustering in RabbitMQ is established in terms of different nodes that basically participate in the same cluster, but basically it provides a way to scale a RabbitMQ deployment. So by default, the clustering mechanism in RabbitMQ provides you with the ability to create different queues in different instances in the cluster, which are independent of each other. And this basically guarantees that if you have more demand for more queues and more processing at the level of the message broker, you just add more instances and you create more queues in those instances. However, if you want to establish high availability, so that once an instance fails, and you want to guarantee that the messages of the queues of that instance still are available, you need to provide an extension of that default clustering mechanism, which is called mirrored queues. And mirrored queues basically provide you with the ability to replicate messages from queues on one instance to one or more queues on another instance based on a specific policy that is being created in the message broker. Now, before we proceed, let's see briefly how does RabbitMQ look like. By default, the installation of RabbitMQ is fairly simple. We have the DB directory, which basically persists both the messages that are received at the level of the message broker and the information about queues, exchanges, bindings, and all of the other elements in the database. So the DB folder basically is the storage mechanism for messages and other types of elements in the message broker. And RabbitMQ uses an NoSQL database called Mnisia. Mnisia basically is a NoSQL database that's provided by the Erlang utilities. And it's quite good, as I might say. The other thing is that in the ebin directory of RabbitMQ, you have the compiled Erlang files, which are ready for execution by the Erlang virtual machine. You have, in the etc directory, you have a default configuration for RabbitMQ, where you can specify not only RabbitMQ configuration parameters, but also RabbitMQ plugin configuration parameters. So if you develop a plugin for RabbitMQ, that plugin can specify some configuration in that file. In the log directory, we have the logs, which you can read, and there is another type of logs, which is called Erlang crash dump logs, which are more low level. They are stored in the sbin directory, and you can read them using a utility called Erlang dump viewer, which is very useful in cases where you get an error from your message broker and you need to investigate it. And the plugins directory basically stores all of the RabbitMQ plugins as archives. There with the easy extension, which stands for Erlang zip. And basically, when you start up your message broker and you have installed some of those plugins, they're unzipped and added as part of your RabbitMQ instance. And the actual utilities that you can use in order to interact with the message broker are also stored in the sbin directory. There is the RabbitMQ plugins utility, which allows you to install or uninstall plugins in the RabbitMQ broker. You also have the RabbitMQ server utility, which allows you to start or stop the message broker. So if I now go to the sbin directory and start up my broker, I can just say RabbitMQ server without any parameter. I can also specify RabbitMQ server start, and it will start up my broker, and I can see that it starts with 9 plugins. One of the plugins that starts as part of the RabbitMQ message broker is the RabbitMQ management console, which is basically a web-based tool for administering the RabbitMQ message broker. This is actually the main tool that allows you to monitor and to configure elements inside your RabbitMQ instances. If I go to the overview tab, I can see that I have currently one instance running, which is Rabbit@Martin. And I can see some parameters for that instance. For example, how many disk space or memory is being used by that instance. And I have 2 other instances which are currently down. And the reason for this is because I have configured a RabbitMQ cluster, but I haven't started the other 2 instances. You can also see how many connections do you have, TCP connections, and how many logical channels inside your message broker. Currently, I have none because I haven't connected any subscribers to the message broker, and I haven't published any messages. And I can also see the exchanges and the queues inside the message broker. As you can see, I have a few system exchanges which are pre-created for me. This is the AMQP default, which is the default exchange. I also have a default direct, Fanout, headers, and topic exchanges, which you can use. But it's typically better to create your own queues, your own exchanges instead of those. You can also see how many queues currently you have created. I have some test queues here. And you can also provide some minimalistic administration of the message broker, such as, for example, creating users or creating virtual hosts inside the message broker. A virtual host typically allows you to separate logically the message broker, and you can create different types of elements in a single virtual host inside the same message broker. This provides you with the ability to create multi-tenancy at the level of the message broker. Now, if I actually want to play around a bit with my RabbitMQ instance, I can use the RabbitMQ Java client. And in order to use the Java client, basically, I have an example for this. Basically, I use a sender class, which is basically a wrapper around the Java client library. I call initialize to initialize that sender, then send some test message, and finally, I destroy the sender. And if I look into these methods in a bit more detail, the initialize basically first creates a so-called connection factory, which is a RabbitMQ Java utility. And from that connection factory, I can create one or more TCP connections by calling factory.newConnection. And when I have a TCP connection, I can create one or more virtual channels that I can use to interact with the message broker, to create queues, to create exchanges, to send messages, or to subscribe to the message broker. After I've initialized my sender, I want to send a test message. And in the send message method, first I make sure that I have declared my queue to which I want to send the message. If I don't do this, and basically I send the message to the default exchange, it may not be delivered in general because there will be no queue created that matches the routing key of that message. And this operation essentially is idempotent, meaning that I can execute the declare queue operation multiple times, and if that queue is already created in the message broker, it will not be recreated again. And after I make sure that I have my queue created, which is called event queue, I send the message by calling the basic publish operation. Behind the scenes, this operation sends an AMQP request of type publish to the message broker that publishes the actual message. I specify the exchange to which I want to publish the message. In that case, it's the default exchange with the empty name. Then I specify a message key, which in my particular case matches the queue name, since I'm using the default exchange. I can specify some parameters here as a map of parameters. And those parameters could be, for example, how long should my message live in the queue before it's being dropped out, if not consumed. Or I can specify a message time to live. And the last parameter actually is the message in terms of stream of bytes. I can also specify some serializable objects that I can send for processing to the message broker. And finally, when I send a message, I would ideally like to destroy my sender. And the way I do this is by just closing the connection. When I close the TCP connection, I close all of the channels that have been opened by that TCP connection. So I don't need to iterate over the channels and close them one by one. Now, if I want to use that utility to send a message, I can go and see basically that in the queue, if I go to the queues tab, I can see that I have one message currently ready, but not consumed. So it's staying in the queue, but it's not consumed. If I want to consume it, I can use a fairly simple subscriber for that purpose. I actually create two competing receiver instances, which are custom classes that represent a subscriber. And for each one of them, I initialize them in the same way I initialized my publisher. Then I sent, say, receiver.receive for each one of the two, and finally destroy them. So actually, we have just published one message to the message broker, and it will be just one receiver that will receive the message. What will happen to the other receiver? Anyone? But what will happen with it? Is the program going to finish? Exception? No? No, it's going basically to hang. So basically, the application will stay and the other broker will wait for a message to become available at the message broker so it can be consumed. So if I run basically this application to consume the message, it would be just one of the brokers that will consume the message, the test message, and the other one will stay until another message is published at the message broker. So basically, as you can see, basically the Java library, as it's used like this, just receives a message. And if we look at the receive method that is used to receive a message, we call the basic consume operation on the message channel to consume the message. And we specify some consumer, which is an instance of a queuing consumer that receives the message. It is a blocking operation that blocks, waits for a message to become available on the queue, and then receives that message, and we print it. And as you can see at this point, this is not a way to listen actively for messages from the queue. You need to block, or if you want to provide an asynchronous listener here, you need to implement it yourself. The Spring Framework provides a listener for that purpose, as we shall see in a few moments. So, going back to the slides, the Spring Framework provides support for RabbitMQ in terms of several distinct frameworks. The first one is the Spring AMQP framework, which is basically the general framework that provides utilities for working with the AMQP protocol. But at present, the only broker that's supported by the framework is RabbitMQ, as an implementation of the AMQP 0.9.1 specification. The other two frameworks that provide support for RabbitMQ are Spring Integration and Spring XD. Spring Integration is an implementation of the so-called enterprise integration patterns, which is a collection of various patterns that allow you, for example, to route messages, to filter messages, to transform them, to split them, and so on and so forth. And basically, the Spring Integration framework provides adapters for plugging with the RabbitMQ instance. And the Spring XD framework is a relatively new framework in the Spring ecosystem. It provides you with the ability to analyze big volumes of data. And in that regard, the Spring XD framework also provides utilities for interacting with the RabbitMQ message broker in terms of distinct adapters. So looking at the Spring AMQP framework, it provides 3 distinct classes for working with RabbitMQ. And basically, they are pretty much different than what we have with the RabbitMQ Java client library, but they're fairly simple to use. The first one is the RabbitAdmin class, which is a Spring utility that allows us to create queues, exchanges, bindings inside the message broker instance. The second one is the ability to create asynchronous listeners that listen for messages from one or more queues in a RabbitMQ message broker. This is something that's not provided by the RabbitMQ Java client library. And the third utility is the Rabbit template class that allows us to send and receive messages from the message broker. Typically, utilities of the Spring AMQP framework can be used directly in Java code or via Spring configuration, whether that's XML or annotation based, as we shall see. So this is how, for example, you may use a RabbitAdmin utility. You create an instance of a caching connection factory, which is a Spring-specific class that represents a factory for creating of TCP connections to the RabbitMQ message broker. Then we create a queue and a topic exchange using beans provided by Spring for the purpose. Then we create an instance of RabbitAdmin, and using that instance, we declare the queue and the exchange on the message broker. And finally, we declare a binding between the queue and the exchange using a very simple DSL provided by the Spring Framework that's being used in the declare binding method. And finally, we destroy that factory. As you can see, it's fairly simple and readable to create that configuration programmatically. If you want to create a listener to one or more queues in the message broker, you can create a simple message listener container from the RabbitMQ container factory. And you can create a listener class which needs to implement the handle message method. If you use Spring configuration, you may customize the name of that method. It may be called receive message or any other name you would like to supply. But by default, this handle message method receives messages as they're consumed from the queues that are specified. And as you can see, in order to set the queues to which you want to listen, you call the setQueueNames method. You may specify either one queue or a list of queues to which you want to bind your listener. And basically that's it. This is how you can create programmatically a listener. And the final utility is the RabbitTemplate utility, which is fairly simple. You just use the convert and send method to send a message to, in that particular case, to the default exchange with some message key, which is sample queue, and some message payload, which is the string sample queue test message. It's as simple as that. However, that approach may not be so good. In many cases, you would really like to separate your business logic of the application from the configuration of RabbitMQ or a database or any other system you would have. And for that reason, it might be much more proper to specify all of these things in Spring configuration, either using the Spring XML configuration or using annotations. And this is how you can, for example, do it. For RabbitTemplate, if you want to create a RabbitTemplate for sending or receiving messages from a broker, you use the Rabbit namespace, which is provided by the Spring Framework. You specify a connection factory, which is also defined in Spring configuration. You specify the exchange and the routing key. And using that template inside the same Spring configuration, you can send and receive messages from the message broker, or inside your application, you can receive and get an instance of that template based on the ID to send and receive messages. For a listener, the situation is pretty much similar. You use the Rabbit namespace to create a listener container, and that listener container must reference some Spring Bean, which is a class that implements a method that is used to receive those messages. And basically, that class is used as the listener implementation. And a listener implementation may look something like this. Pretty simple. We have a class with some method that is used to receive the messages. However, we can make it even more simpler. We can use just a single Spring annotation instead of XML. And basically, this achieves the same purpose. We have the Rabbit listener annotation, for which you can specify also an exchange, a different connection factory, and so on and so forth. By default, it will use a connection factory to a RabbitMQ instance running on localhost on default RabbitMQ port. And in that particular case, I achieve the same purpose by specifying Rabbit listener and one or more queues to which that listener binds. However, if you don't really want to use XML configuration for the other types of elements, such as the Rabbit template or the RabbitAdmin utilities, you can use Spring Boot fairly simply. You can have a Spring Boot application, and inside that Spring Boot application, you can create programmatically beans for the Rabbit template class or for the RabbitAdmin class and use those directly. Apart from the Spring AMQP framework, we have also the Spring Integration framework, which provides several distinct types of elements that allow the Spring Integration framework to integrate with RabbitMQ. And these in particular are the inbound channel adapter and the outbound channel adapter. An inbound channel adapter allows us to read messages from a RabbitMQ instance, and an outbound channel adapter allows us to send messages to a RabbitMQ instance. And we also have an alternative of those called inbound gateway and outbound gateway. The difference is that an inbound gateway allows us to send message, actually to read message from a RabbitMQ instance and to send back a reply to that RabbitMQ instance. And an outbound gateway allows us to send message to a RabbitMQ instance and to receive a reply from that instance. So basically those two utilities allow us to implement request-reply type of communication with the RabbitMQ instances. And to give you a fairly general scenario of where you can use that, for example, if you don't want to use the utilities provided by the RabbitMQ message broker to create message replication from one queue in one RabbitMQ instance to another queue in another RabbitMQ instance, you can use the Spring integration framework for that purpose. We have one instance with a queue called test queue, and we receive messages from that test queue using the inbound channel adapter in a Spring integration application. That message basically is sent over to a test channel, which is a Spring integration specific bean that is like a pipe that allows us to process messages through. And when we send that message to a test channel, it is read from an outbound channel adapter and sent to another RabbitMQ instance. So this is how you basically can create replication between two RabbitMQ instances using Spring integration. You can, of course, use another framework for that purpose, such as Apache Camel. Apache Camel also provides integration with RabbitMQ. And basically, this is how you can create that scenario using Spring configuration. You create the connection factory again, which is the Spring utility for creating TCP connections to a message broker. Then you create two queues. In that particular example, I'm using the same RabbitMQ instance, which is the one running on localhost. Then you create a queue called test queue and a queue called test destination queue. Then you create a template which would be used by the outbound channel adapter to send messages to the test destination queue. And basically I create an inbound channel adapter and an outbound channel adapter for reading messages from the test queue, from the inbound channel adapter and sending it to the test channel. And an outbound channel adapter that basically fetches those messages from the test channel, which is a Spring integration pipe, and sending those messages to the test destination queue in the same broker instance. And this basically everything of this is done just in Spring configuration. You don't need to programmatically do anything. If you want to look at a more complex scenario, let's consider the case that we have an online shop. And this online shop receives different types of orders. A customer creates an order that can contain, for example, a request to buy milk, bread, apples, or rabbits. We'll start with this basic scenario when we have just 4 types of products. And that order processing system may decide to split the different types of orders for processing by different types of distributor applications. For example, milk is delivered by one distributor and bread is delivered by another distributor by means of another application. So we need to implement that system that basically processes different types of orders to different types of systems. And using RabbitMQ and with Spring integration, we can achieve that scenario in the following way. We can receive basically orders in our application, and we can send those orders to a Spring integration channel, which is called test channel. That channel basically sends those orders to the so-called order router, which is basically a utility that routes messages based on their type to different types of other Spring integration channels. For example, if we have an order which contains only milk, it will send that order to the milk channel. If we have an order that's only for rabbits, we'll send that order to a rabbit channel. And for our initial scenario, we'll be assuming that we have only orders with one single type of product. When we send those orders to the channels, they're sent to the outbound channel adapters provided by Spring integration. And from those outbound channel adapters, they are sent to concrete RabbitMQ queues that store basically the different types of orders. This is basically the scenario that we will start with. And we'll see how interestingly can we extend it using the utilities provided by the Spring integration framework. Okay, so for the purpose of the scenario, in order basically to be able to achieve that sending of orders, I've created a very simple DSL, which is in a TXT file which specifies a list of orders. Each order has a type. The first one, for example, has a type of bread. An order has a quantity and some price. And in that particular case, I have 4 types of orders for bread, milk, apple, and rabbit. Inside my Spring configuration, I basically create the entire configuration for Spring integration inside my Spring XML configuration. I create the Spring integration channels. The first is the test channel that will receive any type of order from a customer, and those are created for the specific types of orders. I also create the queues in the RabbitMQ instance for each type of order, bread, milk, apple, and RabbitMQ. I create a RabbitAdmin instance for creating of those queues. I use the so-called payload serializing transformer. This is a utility that allows, a Spring integration utility that allows me to receive messages from one Spring integration channel and to convert those messages in a stream of bytes. And this is convenient because I want to send those messages as a stream of bytes to the RabbitMQ instance for processing. Then basically I create the outbound channel adapters for each type of product. And each outbound channel adapter is bound to a particular channel from which it reads the particular order and sends it to the RabbitMQ instance. In order to establish that particular routing of orders based on type, I use the so-called Spring Integration Router, which is a utility that allows me to route a particular message based on some criteria. In that particular case, I use Spring Expression Language to specify that I want to route a message based on the type of that message and based on order channel as a suffix. For example, if I receive a bread order in the test channel, that order will be sent to the bread order channel. When that order is sent to this bread order channel, the message will be transformed to a stream of bytes using that transformer, and it will be sent to a bread byte order channel. From that channel, it will be further sent to a RabbitMQ instance by means of that outbound channel adapter. And this is basically the initial setup of our application. If I want to test this out, basically, what I have basically is a very simple scenario where I create a Spring context. I get a list of orders by means of parsing that domain-specific language. I'll not go into the parsing details since they are not relevant. And for each type of message, I send it to the test channel, which I retrieve from my Spring configuration. When I do that, basically, I have to wait shortly for those messages to be processed. And when I go back to my RabbitMQ management interface, I can see that I have new types of queues created, an apple, bread, milk, and RabbitMQ, and each one of them has exactly one message. So I've managed to send those orders for processing to a single channel, and they've been successfully routed and sent to RabbitMQ for further processing. Now, so far so good. However, this scenario is fairly simple. So what about the case when I have an order which can contain both bread and milk or different types of orders? I need to support that use case. And for that reason, I need to extend my application in order to support the so-called composite type of order. In the second example, I have the so-called composite type of order introduced, which is essentially an order which may contain child orders. In that particular case, I have one composite order, which has two child orders, which are of the same type, Rabbit. And I want to support that scenario in my Spring integration application. In order to do that, what I want to achieve is basically when I receive a composite type of order, I need to extract all of the child orders and send them back to the test channel for further processing as regular orders that contain just one type of product. So in order to achieve that, I can go to my Spring configuration again. I provide a new channel for handling of composite orders, which is a composite order channel. And I also provide a splitter, which is a Spring integration utility that allows me to receive a message and to split it into multiple other messages. I bind that splitter to the composite order channel, and when I split those messages, I send them back for processing to the test channel. Meaning that since I have a composite order with two Rabbit suborders, both of those Rabbit suborders will be sent to the test channel for further processing. And a splitter basically, if I look at the splitter implementation inside my application, is fairly simple. I just get the orders from my order bin. Basically, an order is represented internally in my application as a simple bin which has a type, quantity, price. And now, in order to support composite orders, I just provide it with also a list of orders, which basically are set during parsing. And this is how a splitter works. I get just one type of message, and it returns me with a list of messages. Okay, so far so good. So we've basically managed to extend our application with composite types of orders. However, in reality, when you go to the shop, you get some, for example, CAS order, or for example, you want to process orders from an invoice or from an image. And basically, in order to do that, you need to support some way to read information from an image that for example, you want to scan an invoice and to receive that information from the image. And for that reason, I would like to introduce yet another type of order, and that's essentially an image type of order. So an image type of order essentially looks like this. I have an order of type image, which has some URL that points me to the image that represents the order. If I look at the two images that I have here, the first one basically is an order of type milk, which has some price. And the second one is a bit more complex. It is a composite order with some price, which has some suborders, which are just of type apple. And what I want to achieve basically is to parse those images, to retrieve the orders, and to send them for processing in my Spring integration flow. And how can I achieve that? If I go to my Spring configuration, again, I introduce a new type of Spring integration channel to process my image type of orders. Here, as you can see it. And when I receive an image type of order, I also create the so-called Spring integration transformer, which basically reads, can provide me with the ability to read the message and to transform it into other type of message. What I want to achieve here is to read an image type of message and to transform it to a regular text-based message that I can process and send to a RabbitMQ instance. And I achieve that by means of the so-called Spring integration transformer. A transformer basically looks like this. So transformer basically provides the transform method, which receives a particular type of message. In that particular case, this is an order of type image. And it returns yet another type of order. Inside my transformer, basically, I use an OCR API, a REST API available publicly, to which I send those images. They are parsed by that OCR API, and I get back information about the text that's contained inside the image. When I get that text, I create a new type of order, which is basically representing the order from that image. Now, if I basically run that example, I have to wait some time for the OCR basically to recognize the image, and I get some JSON result, which contains the parsed content from my two images, which are provided by the two image orders. And then those messages are converted to proper order bins and sent for processing to the Spring integration flow. If I go back to my admin panel, I can see basically that I have now a few more Apple orders and a few more Rabbit orders, which are basically retrieved from those composite type of images. And this is basically how you can create such an integrated application that uses Spring integration and RabbitMQ to achieve that particular scenario of processing different types of products. So as a summary of the talk, basically, when would you like to use the Spring framework to achieve integration with RabbitMQ? If you're you're writing your application in a Spring environment, you ideally would like to use the Spring framework utilities, as they basically provide more flexibility and are, I think, better supported than the RabbitMQ Java client utility. So you definitely need to favor them over the regular RabbitMQ Java library. So, any questions? Yes? So the question basically is to repeat how you can protect the message broker from spamming. Typically, RabbitMQ initially is not targeted to be available as a public service. So one of the targets of RabbitMQ is to be used internally to route messages between systems internally or between components internally. So in that regard, it would be the control of those systems to make sure that they do not overload the message broker. However, you may provide different things at the level of the message broker to make sure that you don't overload the message broker. For example, you can specify maximum queue size. When you create your queue, in the properties of your queue, you can specify that you can have up to, for example, 10,000 messages. And after that limit is passed, basically you can just drop the messages, or you can send the excessive messages to the so-called dead letter queue, where they are further processed, and so on and so forth. So this is one factor that you can use, is to limit basically the storage at the queue level in the message broker. Another thing basically you can achieve, if let's say you have a scenario where you want to provide RabbitMQ as a public service, and you want to make sure that basically you don't want to overload the RabbitMQ message broker, is to deploy a solution such as a proxy that makes sure that you don't overload the message broker. I think these are some alternatives. Any other questions? Yeah?
Performance, different type of RabbitMQ message. I mean in the STOMP or AMQP 091 or 1.0.
So basically your question is whether AMQP 1.0 is more performant than 0.91, which is supported by RabbitMQ. Yes. Okay, so basically, yeah, maybe to provide some context for people as well, RabbitMQ currently supports only version 0.9.1 of the protocol, which is not the latest one. And they are very bound to that particular version, and it's very difficult for them to update to 1.0 of AMQP. And they have an experimental plugin that provides support for AMQP 1.0, but it's not so much tightly integrated with the message broker. So in that reason, if you want to use AMQP 1.0, you have to either use that plugin for RabbitMQ, or you have to consider maybe other message broker. But in fact, AMQP 1.0 provides some enhancements compared to the older version, so you're welcome. Other questions? Okay, if not, then thank you for attending the talk.